Hello everyone, we are Team SumText. Welcome to our presentation. When you open a new site, do you just start reading every news article? Probably not. We typically glance at a short summary and then read more details if interested. Text summarization is the process of summarizing information in large text for quicker consumption. Since manual text summarization is a time-expensive task, the automation of this task has been gaining increasing popularity. And this project is to research, design, and implement with various models that can make automatic text summarization. In terms of our data, our main data set is the CNN Daily Mail data set. We split the data set into training, validation, and testing. And for each of them, they have a news article as well as the reference summary. We also web scraped the 74 recent news articles from BBC for manual labeling. For the data processing part, we removed all irrelevant elements as well as tokenized sentences. In terms of the model, we used the first three sentences from the news article as our extractive baseline. For the abstractive summarization, we first tried the encoder, decoder, and recurrent neural network, but the result was not good. Then we implement GPT-2 because this is the first transformer that we were exposed to. And then we did some research, and we found that sequence-to-sequence transformer might have a better performance. So we implement BART as well as T5.
So when we trained our model, the metric we used was BERT score. So BERT score is an automatic metric that is capable of measuring the semantical similarity between the reference summary and the generated summary. So the figure shows in detail how BERT score works. It basically uses BERT pre-trained contextual embedding and computes similarity as shown on the right side. So higher score indicates higher semantical similarity between the generated summary and the reference summary. So here are the results on the test tab for each models in terms of BERT score. So you can see that T5 and BART outperforms other models. However, although BERT score is a great metric, it's really helpful for training purposes. It cannot measure how well our model performs, especially in terms of conciseness. That's why we need manual scoring. So this flowchart shows how we did manual scoring. For this part, we used 74 recent news articles, as mentioned before. And for each generated summary, we will give manual score from 3 dimensions, which are accuracy of the content, readability and grammar, and conciseness and balance. And for the score is from 1 to 3. So 1 represents poor performance, and 2 represents fair performance with some defects, and 3 represents great performance. So the table shows the outcome of manual scoring. And you can see that using the first 3 sentences method actually performs really well in terms of accuracy of content and readability. However, it performs significantly worse than other 3 models in terms of conciseness. And overall speaking, T5 and BART model we use performs really well and have a good balance in terms of conciseness, accuracy of content, and readability. So here are one example. So this article mainly talks about Elon Musk. After he bought Twitter, he demanded Twitter staff to fully commit to working and follow some strict new rules. Otherwise, they will be fired. So this article have about 650 words in total. And here are the outcomes of the summarization. So as you can see, the outcomes shows that it basically matches our conclusion mentioned before. So for the first 3 sentences method, the output is really long and compared to other outputs. And for GPT-2 outputs, if you look closely, you can see it's not accurate. And overall T5 and BART produce excellent results from our point of view. And we also have some other interesting findings during the manual scoring process. For example, like we found that the extractive summarizer performs really well when dealing with news article describing a major event. However, it performs poorly when dealing with news article describing an individual story.
In conclusion, T5 and BART, they have a better performance than GPT-2 in terms of news summarization. One thing is that in sequence-to-sequence transformer, we have articles as input and the summaries as target. But when we fine-tune GPT-2, we need to combine articles and the summaries together as inputs as well as target. Another thing is that because GPT-2 is designed for text generation, so its performance of extracting ideas from the given text is worse than the sequence-to-sequence transformer. And we also tried multiple decoding methods. When we do greedy search, it seems like the model is easier to repeat the same sentences, and those are the other results below. And in a similar project, we would spend less time on the encoder-decoder recurrent neural networks, and also we would combine iterative and abstractive method together to leverage the advantage on both methodologies. And this ends our presentation. Thank you, everyone.